Alright guys, it's time to start the second lecture about domain modeling. Next week you will be having a workshop about domain modeling, so we'll go through the basics on this lecture and a little bit more advanced concepts for the next lecture. The screen is not shared. So, first of all, if you have not noticed, the first lecture is up. You can watch the movies on YouTube. One thing to maybe notice is that if you go to YouTube and watch them, you can set the speed. I'll just pause. You should be able to set the speed here somewhere. And also funny subtitles. That can be a little bit fun to watch. You can also watch the stream via Adobe Connect. You can download the PDF from the whiteboard, and you can also take a look at the source code on GitHub. Feel free to add your own implementations of the dice game that we did. If you feel that you would like to contribute to the course, you can do it by pushing your code to this repository here. We have the Java implementation, our 3 classes there, so you can take a look at them and maybe find some errors. There probably are. Yeah, once more I will remind you to register for the course. If you have trouble registering, send me an email. I registered a bunch of people yesterday. I will register another bunch this afternoon. If you have not yet registered, try Ladoc first. If that's not working for you, send me a mail with your personal number and the program you are studying, so I can look into that. Short recapitulation of what we did last lecture. We looked at analysis and design and where it fits in the process that we use. We took a look at why we need analysis and design, and we had this example of the semantic gap problem that faces if we have a somewhat advanced idea. It's a very big step to just go down into machine code and make a version of the system that the CPU wants. So we need to take smaller steps, and analysis and design are good middle steps to take here, as well as writing code in a high-level language. We also have the opportunity to catch errors earlier on than to introduce them as bugs in the system. We took a look at why we need object orientation, and we discussed abstractions, encapsulation, and hierarchies as tools humans use throughout our daily lives to handle complexity. And if we have a method that supports these ways of handling complexity in itself, that should be an advantage to us. So object orientation is there to make it easier for you. And finally, we made a short, small example here, going from a requirement, doing some domain modeling, understanding the requirement a little bit more, finding some strange mistakes in it, details that were omitted, that is maybe not that easy to spot in text, that you kind of like assume that, oh, of course it should be 2 dice. We made a dynamic view over the working software using an interaction diagram, a sequence diagram to be more precise, looking at how do the objects in the software actually speak to each other. What object sends what messages to what other objects. And using this diagram, we could then construct a class diagram also. Since we could see that the dice game object needs to send messages to two different die objects, we need two relations from the dice game class to the die class. Questions? All right then. See you in 10 weeks for the exam. No, of course, this was kind of made ad hoc. We just did something here, and it was a very small problem, of course, so maybe it was a little bit easier than it is in reality. But we will talk a little bit more today about how to develop a domain model. So, first things first, what is a domain then? Anyone has an idea about what a domain is? A domain on the internet? No, that's not really what I'm after, but the domain is a delimited problem area. That is a specific area that you're trying to understand. It could be banking, for example. Loans and rents and stuff like that. It could be insurance, the insurance domain. It could be air traffic control domain. It could be built-in software for managing brakes on a car. That's a domain also. A specific type of game could be a domain. A real-time strategy domain. So, thinking a little bit about that, what domains have you been developing software in so far in your studies? What kind of laboratory exercises and projects have you been doing? I know that in the C# course at least you do some kind of recipe collection. Some of you have been doing a little bit about games. I also know that in the iterative development you did a laboratory exercise about triangles. So, in education, we often use quite familiar domains. Domains that you have knowledge about already. You have an idea about how does a recipe collection work. I know what a recipe is. I've been looking at cookbooks and stuff like that. Also, we use quite defined domains. A triangle is a mathematical concept. The domain is defined, and you can read about it, and it's not problematic in that way. So it's a great advantage to be in a domain that is familiar to you, because you don't really have to learn the problem area first. But if you face a problem area that you don't understand, or you don't have a great knowledge about, you need some kind of tool to understand the domain. For example, insurance policies and stuff like that. Not many people know how they actually work. So if you go out to a customer, they probably have a domain that you know nothing about. They probably don't want a blog or an image gallery or a recipe database. They probably want something that is quite specific for them and quite hard for you to understand. That's is one of the fun parts about software development, actually, because you have to learn something else also, not just be an expert at programming or IT or software development, but you also need to penetrate other domains, because your applications are supposed to help people solve problems in their domains. So we need a tool for this, and this is our domain model. Everyone seems so very serious. So we have our domain, and we need to make a model over it. So it's a It's a visual guide containing important concepts and relation between these concepts. A keyword here is visual. Most of the information that we need to make the domain model is often in the requirements, but there they are in text form. And using just text, it's quite hard to figure out relations between stuff, because we cannot really remember that much when we read stuff. So we are visual creatures. We tend to find problems in visual diagrams and stuff that looks wonky quite fast. But in text only, it is much harder for us. Yeah, the use case model is one model that can be used to visualize requirements, but the domain model is a complement to the use case model. Yeah, the domain model is used for communicate and understand. And this can be, of course, between developers or users, customers, domain experts, and the developer. And as we saw also, we can find problems in the requirements by using our domain model. We can also use it to find improvements to our requirements. Maybe the requirements are not optimal in some way. They probably aren't. using the domain model, we can spot things that we can change in our requirements to make the solution even better. The good thing about the domain model is that it's not about software at all. So you are really, really free here to understand the problem and not think about, oh, how should this work in software? And that's a great advantage. But it's also quite hard to remove the software thinking hat, especially for you guys that like programming and that like developing software. So try to remove the, oh, how should this work in software thinking, and remove all things that are about software when you do your domain models. So, the relationship between the requirements and the domain model then. Just as was mentioned here in the chat, we have another model called the use case model. If you remember back, way back, we have these actors, these guys, these types of users that can do different things here. They can start different use cases. They can do stuff. Anyone remembers? These are basically your requirements, but maybe in a visual kind of way. To get an overview of the requirements, you can draw these little guys and do arrows to the use cases they can start, the requirements they can execute, so to speak. And in this, you write text mainly. Your requirements are mainly in text form, maybe some images and stuff like that that is needed to understand the requirement. But mainly it's text. Maybe a few of these diagrams are good to have. But anyway, here we have activities. Behavior. Rules. Dynamics. What is happening? The user should do this. The system asks for more information. The user gives more information. The system computes something and gives an answer. So we define the rules for these behaviors, what users can do what stuff in our system in this part of the... Yeah, the circle, or they should be kind of like ellipses. They represent a use case, a requirement. You can read more about the use case model in the book if you want to. So I will just draw a simple class diagram like that, maybe. And here we have our analysis model. The requirements delimits the analysis model. We should not go beyond our requirements in our domain model. And our domain model, our analysis model, refines the requirements. We find problems, we find missing details. We find assumptions that we have made when writing the requirements that maybe are not valid. We find improvements. This aspect of the system is about information, relations, what is actually needed to support the requirements. So we have a more dynamic side of things and a more information and static side of things. And they complement each other. Some things are good to express in the requirements, for example, rules. Some things are good to express in the analysis model, for example, information and relation between these entities that we have. So the analysis model is not a straightforward copy of the requirements model, and vice versa. They complement each other. So that is important to think about. So if you face maybe a complex requirement with a lot of rules in it, maybe that part is not so easy or good to describe in an analysis model. If you think back to our small dice game, there was a description of the rules, the win rule there, but there were no real concept about that in the domain model. Questions? People often find domain modeling to be hard because it's hard to say that something is really, really wrong. It's also hard to say that something is really, really right. It's more of a scale between bad and good, worse or better. And we will think about some rules of thumb during the rest of these 2 lectures about domain modeling that you should use to judge your domain model. Since the goal of the domain model is to communicate and understand, you can often add stuff to the domain model that supports understanding, but could be bad in other ways. For example, making it more complex. This makes domain modeling hard. And hard to understand also. Because it's not a button that you press and it compiles and, oh, you had some kind of error in your model. And then you get a black and white answer if it's correct or not. I get a question here from the chat. How should we think of domains as a metaphor? What does the word represent in a more precise description? That was a hard question. På svenska hade jag sagt problemområde. Yeah. Yeah, you can of course have different domains. Exactly. You have the web domain. That is more of a quite a good broad domain. All web systems are within the web domain. So you can of course create domains based more on technical constraints or a technical area. All built-in systems could be one type of domain if you would like. A very large one, because it is probably very different between creating a software for a DVD recorder or brake control software in a car, or something in an airplane, or a missile guiding system. I think the domain should be as narrow as possible, not as broad as possible in your application that is supposed to be developed. If you have several different domains, which you could have, it is better to make several domain models also. So try to keep your domains in one area, one specific area. And if you need several domain models, that is fine. But it's not often a good idea to mix them, because the resulting model will be 2 times as complex and not as understandable. I don't think one domain model for each feature, but you could probably group features that have some kind of similar domain and have them in the same domain model. Yeah, okay, what's the time? So a quick example just to take a look at some UML notation. So here we have a class. It's this box that has 2 compartments. The first compartment is for the class name, and the second compartment is for attributes. That is information that this class can handle. As we are focusing on analysis, this is all we need in a class actually. When we do design later on, we also add operations to it, functions, member functions, or what you are used to them being called. But this is not done in the domain model. So we have 2 concepts here, 2 conceptual classes, the person class and the vehicle class. And we could link these 2 together if our requirement states that, oh, we need to know about persons that are connected to vehicles or vice versa in some way. This is called an association. One thing that is neat about the UML is that you can use the same notation but have different levels of detail. And this is kind of a high level of detail that we have. So this is how our associations look when doing domain modeling. They are just a solid line between the classes. Later on, when we do design, we will add more details to this and more rules to these lines. So, but let's set a name for this relation. Let's just say that we need to know about what person owns what vehicles. Maybe we're doing an insurance system of some sort. We're doing an accident reporting domain or insurance domain. So we need to know a vehicle has been in an accident, we need to know who owns this vehicle. So we have a name. And here it's important to find the names from the requirements that actually mean something, and just not say has, contains, is in, but try to find the association names that actually means something from the requirements. In this case, it's a legal ownership of the vehicle. And we can also add some more information, as we saw. It is likely that a person can now own more vehicles, probably as many as they want to. It is also, in our system, not likely to have people registered in the system that does not own a vehicle. It would not be making sense to have a lot of people that don't own vehicles. So we say that to be able to be a person in our system, you need at least one vehicle, but you can have many. And vice versa, we don't want any loose vehicles. We don't want any vehicles that don't have an owner. That is a bad thing for us. And this is stuff that you need to ask your users, your domain experts about. You cannot just assume, of course. But in this case, we can. Could also be interesting to know who actually drove the vehicle, who was the driver when the accident happened. Because that's not certain that it is the owner, of course. So we can add multiple relations between the same two classes if we need more information. This stuff here, I'll circle it. Is called multiplicity. And that is a good thing to think about when doing your domain model. But it's not always a good idea to add it for every association that you have. Add it where it's interesting. Or maybe you need to think a little bit about it. For example, the drives association is not that interesting maybe to add multiplicity to. Do you see any resemblance with any kind of other modeling that you have been doing? Conceptual modeling in the database course is very similar to this. But in database modeling, you have a few more rules. You have these many-to-many and stuff like that to kind of solve in a relationship database later on. But you don't need to think about that here. But it is very, very similar. And the concept of domain modeling is an offspring from database modeling. But we are free here to think about the problem and not about how to solve it in a database. So we have a little bit more notation here that we can have. Of course, we can have different kinds of vehicles. So we can put another relation between the classes here. specialization, generalization, specialization relation. Maybe more commonly known as inheritance, at least when we go to design or implementation of design.
Does it need to be arrows?
Yeah, these needs to be arrows because we need to know what is the more general concept and what is a more special concept. A car is a more special concept than a vehicle.
Would it be possible to use subdomains? So vehicles is its own domain in this whole concept.
Yeah, if it's
You have one complete domain, but then you have subdomains like vehicles and things that contains cars and boats.
you mean making a different diagram for the vehicle domain, so to speak. Yeah, you could of course do it if it's very complex. You could of course break it out in another diagram. I could imagine that the vehicle domain in itself can be very complex and maybe also a bit outside what is needed for the actual problem domain that we are in now. You could probably do a lot about engines and stuff like that in a generic vehicle domain. And that is maybe not a good idea if it's not needed for solving our problem. So you should not go overboard with that kind of those kind of side tracks.
So let's say this is a huge system that actually needs all these inputs about vehicles, etc. So instead of having one huge domain model, you can divide that into like subdomain models. You just refer to them as subdomain model 1, 2, 3.
Yeah, that would be a good idea. If the diagram would be too complex or too large to handle, you should of course divide it up in smaller chunks. And one such idea could be to just, okay, about this part we end here at the vehicle concept, but it is actually more detailed than that, and you can display that in another model. That is a good idea. Yeah, and we have one final little thing to show that you often see in UML diagrams, at least. Anyone has seen a UML diagram that has these kind of small diamonds in it? If you Google UML diagram, you will probably get a lot of diagrams that have these kind of like small diamonds everywhere. Actually, this is not stranger than association. It's an association with an added level of detail, and it is called a composition. And we use that to indicate a strong whole-part relationship between the car and the wheel. In this case, we also have defined that a car has 3 or 4 wheels. We'll talk a little bit more about that towards the end of this lecture, I hope. And we will see how it can be used, if at all. But you should not be startled if you see those diamonds in UML diagrams. You can just think about them as associations, actually. They work in the same way. Yeah, exactly as it is said here on in the chat. A wheel cannot be without a car. You cannot have loose wheels here. And also if you throw away the car object, the wheel objects will also kind of die. All right, this is kind of like the notation that you are supposed to master regarding domain modeling. It is not really more advanced than this. You need to be able to draw boxes. You need to be able to draw lines. And you need to be able to think about the multiplicity, think about generalization and specialization, and attributes. So the mechanics actually of writing these diagrams is quite easy. The problematic stuff is, of course, finding the right concepts, finding the right relations that makes up a good domain model for you. So a few hints on how to do that then. I actually think that this is quite a good metaphor that he has found in the book. You should think like a mapmaker. And how does Mapmaker things? They use the vocabulary of the users. If they call a city Kalmar, it will say Kalmar on the map. It won't say some other name. Oi. You can't include everything on a map. Every tree, every bush, every house cannot be included on a map over the entire world, or it will be a very large map. So don't include too much information, too much details. And also, as I said, some things are better to describe in requirements. Behavior, dynamics, rules. Don't add stuff that does not exist in the domain. It's not good for a mapmaker to add a mountain or a river just because he thinks that, oh, this would be neat. Oops. The biggest problem for students is that they tend to start adding software concepts. Oh, we need a database. Let's add that to the domain model. And we also have discussed a little bit about this multiple domain issues. Use experts or other sources. A Mapmaker would definitely try to get a hold of other maps of the area first. People that have visited the area. Of course, you should use any type of user, any type of expert that you can get a hold of. Of course, you should read books about it. If you're doing a robotic simulation software, you better read up about robots. What type of robots does the company manufacture? Is it welding robots, painting robots? Is it generic robots? How many axes do they have? Are there different kind of types of robots in this company? What does their competitors use? If you're lucky, you can get a hold of existing models, maybe from other projects. Maybe you can buy a model from another company. Some domains are quite extensively researched already. So maybe you can get a model, reuse it, tweak it to suit your purposes. Test if the model can't be used. Exactly. Also stuff that don't exist in the current iteration is important to not include up here. Test if the model can be used. Can your fellow developer understand the problem area? Or is he as clueless as he was before looking at the model? Then it's probably not a very good model. Can the end users or the domain experts understand the model? Do they recognize themselves here? A Mapmaker would, of course, give the map to both people that are supposed to travel in the area and those who already live there, and ask them is this map correct? Is this mountain over here? Is it this high? If they don't recognize themselves on the map, it's probably not a very good map. So think like a Mapmaker. Questions? So, okay, we have been doing a little bit an overview of what you're supposed to do, how it's supposed to look, how you're supposed to think. In the next part, we will look more into more detail about finding classes and relations between classes and problems or opportunities that you can find when doing this. But first, 15 minutes of a break.